Welcome back to No Limit Hold'em 1001. Today we're going to be talking about multi-street games, or games played across multiple streets. The learning outcomes today. So first, we're going to use alpha to solve some games played across multiple streets. And we're also going to be talking about how attacking and defending strategies are different between multiple street games and one-street games. So looking back to the Ace-King-Queen game, here we have Oscar, who is out of position, is dealt just the king, and India, who is in position, is dealt the ace 10% of the time and the queen 90% of the time. We have a pot size of 1 and a stack size of 13, and for 3 streets to flop the turn the river, India has the option to either bet 100% of the pot or check. So we already know what the solution to the river is from our video on the Ace-King-Queen games. Because the bet size is 100% of the pot, alpha is going to be 0.5, and so India will bet the queen at a bluff to value ratio of 0.5, so for her 10% ace, she will bet 5% queen on the river. Thinking back one street now, we know what will happen on the river, and so if we're India, we want to bet with a range such that Oscar will face a 0 EV decision to call with the king. So we know that if we bet the river, Oscar has a 0 EV decision with the king. We also want to use this information to make Oscar's king indifferent against our turn bet as well. India can do this by bluffing some additional queen hands on the turn, looking to check back and give up on the pot on the river. Here we see that India has a 15% betting range on the river, and she can use alpha to calculate her turn bluffing range. So with a bluff to value ratio of 0.5, she's going to bet an additional 7.5% queen to match the 15% betting range that she will bet on the river. So her total range here on the turn will be 22.5%. 10% of that is the ace, and 12.5% of that is the queen. When we move to the river, she will bet the 15% range we talked about earlier and check back 7.5% of the queen. And this way, Oscar is indifferent. Oscar will have to pay 1 bet to win 3, but he knows he's going to face a river bet 2/3 of the time. And so Oscar is indifferent against India's betting strategy here. And Oscar's counter strategy is to just fold the turn at alpha as well. So we can just move that back again one street. We've got a 22.5% betting range on the turn. And so with a bluff to value ratio of 0.5, we also have to bluff bet an additional 11.25% queen on the flop, which gives up on the turn. Once again, Oscar will fold at alpha, which is 0.5. And so here we have a solution for India's strategy. On the flop, India will bet 33.75% of her range. On the turn, she'll bet 22.5% of her range and check back 11.25% of her range. Of that 22.5% that is bet on the turn, on the river, 15% of that will be bet, and 7.5% of that will be checked. And the final betting range on the river will be the 10% ace and the 5% queen we have from the Ace-King-Queen game, which we solved a few videos ago. Oscar's strategy would just be to fold at alpha on all 3 streets. If we generalize it a little bit more, we have Oscar always being dealt the king, and India being dealt the ace 100% of the time, and the queen the remainder of the time. We have a stack size of n, and here India can choose which bet size she wants to use on each street. Once again, Oscar will fold at alpha against any bet in order to make India's bluffs indifferent on that street. So if India bets S1 on the flop, S2 on the turn, S3 on the river, Oscar will fold each street at Alpha 1, Alpha 2, and Alpha 3, respectively. So for a strategy for India, India knows that against Oscar's best counter strategy, the queen will have 0 EV to be bet. And so her aim will be to maximize the EV of her ace. And if she does this, she will win as much EV from Oscar's king as possible. Since her ace always wins, she wants somehow to get all the money in by or on the river. Now if she bets all 3 streets, S1, S2 and S3, aiming to get all in by the river, then the pot size on the river, 1 plus 2n, which is the pot size to start off with, plus both players' stacks, is equal to 1 plus 2s1 times 1 plus 2s2 times 1 plus 2s3, which is the amount that the pot grows on each street multiplied together. And so her bluff to value ratio on each street is given by this formula here. Its Bn is equal to the multiple of 1 plus alpha I minus 1. And we'll have a look at an example now. So if India bets 50% on the flop, 100% on the turn, and 200% on the river, the bluff to value ratio which uses on the flop is going to be 1 plus alpha from the flop multiplied by 1 plus alpha from the turn multiplied by 1 plus alpha from the river, and then we subtract 1 and we get 7 over 3. So if t is equal to 0.1, which means that she has an ace 10% of the time, the amount that she would bluff the queen on the flop is 23.33%, and she would check the remaining 66.67% that she has of her queen. Now we know with this strategy that Oscar is indifferent between calling and folding when he faces a bet on the flop. And so when he faces a bet on the flop, his EV is 0 and India's EV is 1. And so the total EV of this game for India is going to be exactly the frequency at which she bets the flop, which is 1 plus her bluff to value ratio times t, which is how often she has a value hand. And this equation for EV is maximized when alpha 1 is equal to alpha 2 is equal to alpha 3. In other words, the bet size on each street is the same. And so S star, which is the optimal bet size, can be calculated here as a function of the starting stack size. So here, if we have a starting stack size of 100, we would know that the optimal bet size on each street, which is exactly the same on each street, is going to be 242.89%. So with a pot size of 1 and a starting stack size of 100, India will bet 2.43 times the pot on each street, with the last bet being all in. So in summary, in multi-street games, the attacking player bluffs more on earlier streets and gives up some of those bluffs on each street. And the fraction that they give up on each street is related to the bet size on the previous street. And we use alpha to calculate that fraction. If the attacker is perfectly polar, then their aim should be to bet the exact same bet size on each street and get all in on the river. And the defender will fold at alpha on each street, depending on which bet size the attacker chooses. That's the end of this lecture. Thank you for listening.